Hey there, welcome to episode 27 of the Quaggling Sand audio program. I'm your host, Dan Hugo. We are recording this on the morning of Wednesday, May 15, 2024. My slightly easier weekly audio program production schedule has moved the Let's Innovate for Vegas audio program to releasing on Tuesday, where it was releasing on Friday with the Cafe Genius Impresarios program. So now, this week, first week with Tuesday, Let's Innovate for Vegas, Wednesday, Quaggling Sand, Thursday, FFS Talk, Friday, Cafe Genius Impresarios. One of these days, I will find someone who wants to be a guest. I have to be honest, I haven't been looking. It's a lot easier to produce a solo show. But guests will be welcome, I promise. They are already. But I don't know who would want to come on this show. Maybe we can talk about your stories, compare notes. Like today, for episode 27, I will be talking about building computers, which is something I've done many times. But I will describe what is, I think, like an indicator of mindset or approach to problem solving, maybe lateral thinking. And I think this is A, not as prevalent as it could or should be, and B, essential for our near-term and even distant future. Thinking globally, but it might be a situation you can address in your own home. Building a computer. So, wherever you found this audio program, hopefully you can see the show notes in the episode description. The summary of today's show: Tinker Toys, Lincoln Logs, Lego products of various kinds, kits or otherwise, and a Volkswagen Bug were all mile markers along the way towards computer engineering, wherein one knows computers by building computers. So all the toys and stuff I've mentioned, the toys, the car, the Volkswagen was of course meant to be maintained by its owner. Reasonably easy to fix, especially back in the day. When they became trendy, it was a little bit more expensive. But certainly, 10, 14, 17 millimeter, everything. I think it was 14, right? 10, 14, 17. 17 was lugs. Was 14 somewhere? It was 10 and 17 for sure. That's just from memory. Anyway, hopefully you can find the links for today's episode in the right where you saw the show notes. Do know that I will be updating this first link, the buymeacoffee.com/DanHugo. That links to a profile page when we get the various web properties for all those programs I mentioned and all various other things up and running. All those links will be updated to point to our primary points of publication. But right now you can find this and the other audio programs on various podcast websites. Remember, Google Podcast has been end-of-lifed in favor of YouTube music or podcasts or something. Who knows? So I have YouTube accounts set up. I just have to migrate the RSS feeds, but I do want to do some. Anyway, I have some administrata to do, but something to be aware of if you want to support this show and the other shows and various projects, which are all powered by coffee. You are more than welcome to, but under no obligation, to buy me a coffee. I do have some of my favorite coffee beans linked on my Buy Me a Coffee profile page. And right below it, the usual ko-fi.com, ko-fi.com/DanHugo. Similar idea, not as much information at this time, but it's another tool to make use of. I'm going to list several toys, Tinker Toys. These are Wikipedia pages. Tinker Toys, Lincoln Logs, Lego, and I want to say it's Lego plastic bricks, but I couldn't, they didn't make it immediately obvious on their website. So you can track that down if you want. It's not Legos. There's no S in Lego. The plural of Lego is Lego plastic bricks, I think, or construction bricks or something. I think it's plastic bricks because they do make a big deal about their plastics, and rightfully so. Fischer Technik. This is a German toy, construction toy. I do not remember where I came upon these, but I do remember on seeing the close-up of the block the building unit. I know I have used these somewhere. I don't know if we had them when I was young, but all of these toys, all these construction toys are sort of take it to the next level. You can get an action figure, but can you build a base? Can you build a house? Can you build a car that they will drive or live or probably fight from? I have a link to the VW Beetle, also on Wikipedia. All these are Wikipedia links this week. The VW Beetle, sometimes called the Bug, which I mentioned, my first car. If Lego was going to build a car, it would have been the Volkswagen Beetle, or vice versa. And finally, a link to Slurp, SLIRP. If you don't know what that is, you're probably better off, but it did play a weird role in the story here today, so I have that link there for your information. So, in the early years, we lived in New Jersey in a house on Graphic Boulevard, and we had a basement. Not uncommon back on that side of the country and in those times. The basement was huge. It was basically the size of the house. So there was a workshop room, laundry, train set up, water heater, boiler with very stinky oil that was delivered every month or so, I think. But the star of the show in our basement was the playroom area, an old couch, and a variety of toys, some of which I have listed. My younger sister and I had pretty much free reign over, what went where, what was in active use at any given time, and so on. So, I will say the big Tinker Toys were probably the most interesting early on. Now, you've probably seen Tinker Toys. You may remember what they are. You can check them out on the Wikipedia site. I couldn't immediately find evidence of the oversized Tinker Toys. So if you can remember the wheels, the round pieces of wood or whatever material they're using nowadays, that you would insert pieces, tubes or sticks, I guess. So for the oversized, the wheels were probably about the size of a 10-pound plate if you go to the gym. Maybe the size of maybe bigger than a 45 record. These are references that most people won't get. The size of a personal pan pizza at Pizza Hut. Are they still in business? I'm going to say like a 6-inch diameter or so. So these wheels, they came in two styles. One was similar to the Tinker Toy wheels with one hole, like an axle, like a bicycle wheel, and then places around the edge where you could place the sticks, or in this case, the tubes. And then there was another kind of wheel that had the center hole and then 4 more holes. So it looked kind of like it kind of looked like a threader, if you're familiar with that is. A threading device that you can thread a rod or some, so make your own bolts. But yeah, these things were definitely oversized. And then the sticks of the Tinker Toy set were these plastic tubes. They were, I think the green were the short ones, the blue. So green was probably something under a foot, probably 6-8 inches. The blue were probably 2 feet. So green, blue. I don't know if there was yellow. I know red were the longer ones, probably 3 feet. There may have been another length. Either way, the Tinker Toys were useful. And at that size, no real danger of small parts to swallow. So those were actually pretty fun. I was prone to taking things apart if it was a form of technology. I remember I think it was my sister had a weird scooter thing. It had a battery with a motor, and there wasn't really much to take apart, but I remember being fascinated by the motor battery assembly. It was a large, I guess you would call it like a floodlight battery. I don't even know if they make them anymore. These huge batteries. I don't even know what letter size it was. But anyway, the giant batteries that you would find in a large flashlight or this little scooter thing. But I was fascinated by how things worked, but I had no idea how to put things back together. That would come later, although I still don't like putting things back together. So I wasn't really into assembling or reassembling early on. Luckily, that's where the construction toys would come into play. So rather than, you can't take apart something that's already disassembled. So starting with the Tinker Toys, the Lincoln Logs were probably the least used, in that the Lincoln Logs were pretty much for building log cabins. So you can build different log cabins. The problem for me, especially with Lego, I never really had an interest back then in building or making the thing illustrated on the tin or in the instructions, quote unquote, the instructions. Like I said, maybe Lincoln Logs, maybe, because really you could build, and they were very practical. I mean, they were pretty realistic. They were just scaled down the way a log works, where you have the cutouts so that you can cross build them on, the joints are basically not really quite interference, but so you can build this thing. They had little pieces of different lengths. You could build different floor plans. Strangely, but very specifically educational, but not quite the open-ended build whatever you want with Lego. Similar could be said with the Tinker Toys. You really couldn't go too crazy, and the Fisher Technic also. You could build some cool things, but I think Lego, even back then, and they've only gotten more crazy. Although they've also become very specialized, which I'm not sure if that's great. I haven't looked recently to see if they have the expert builder parts, which I was always a fan of. But eventually, so I didn't like building. I like to make my own stuff. But eventually, following the instructions did become important. That's what engineering is, especially when we get to the car maintenance days. You pretty much have to, you can't make up your own stuff quite so easily when you're changing your oil. And ultimately, I think setting up for the outside the box thinking, that is almost essential, but it certainly helps in the various pursuits of my career in computer engineering and other tangential, somewhat adjacent fields. Learning how to follow a spec or build the actual thing is probably a good path towards problem solving in general, being able to know how something is supposed to work, how it's supposed to be assembled, so you can find out where things may have gone awry. Engineering is mostly about implementing a specification. To some degree, you can innovate. That's always a good idea. But sometimes it's really about building the thing, but building it safely, cheaply, quickly, changing materials, cost reducing, whatever the particular scenario is. But you pretty much, that's why you have engineering specifications. If you could just build whatever you want, you would have engineering jazz. Parts don't tend to fit together as well unless everything works out just great. And then next time, it could be totally different. But there's plenty of room for lateral thinking, which I think emerges early if we can try out ideas without the constraint of rules or instructions. So in other words, if you start out being told, build this, put this there, put this here, and this is just for my personal thing, I'm not a child psychologist, I don't have any education credentials of any kind, but it seems to me that if you start off with, here are the rules, you must follow them, you're less inclined to develop a tendency to eschew the rules and try out your own ideas. So if that's where you begin, like, I'm not even going to bother with trying to figure out what to build with these Legos. I'm just going to build what I want to build. Throw those instructions away. I cannot imagine spending money on the Millennium Falcon kit and not building it, but that's a different thing. Like I said, I think Legos have become very specialized now. Like, they still, this is not really a bad thing, but my favorite Lego kits were like, here's something with wings and wheels and some other parts that you could build an airplane. Oh, you're not going to build an airplane? Okay. You can do other things with it. I had an expert builder engine kit. I had an expert builder spare parts kit with drive shafts and connectors. And anyway, so great stuff. I think for me, that was essential to enable or plant the seeds of eventual lateral thinking. I'd like to think I have pretty reasonable lateral thinking skills. I would say they began to emerge when I was essentially given the freedom to think laterally rather than following the directions. Eventually, we were in New Jersey until I was age 5, just turning 6. Yeah, I think I commenced going to school in Glendale, Arizona in like April of when I was age 6, about to turn 6. So many years later, probably almost 10. My first vehicle was a 1970 Volkswagen Bug when I was in high school. Driver's license at 16 years of age. My first car, not a looker, but I much preferred a functioning vehicle to a pretty vehicle. In other words, you can have a really nice paint job and get stuck on the side of the road, or you can make it home and have a 53 painted on the front of your weird sort of yellowish, creamy yellow colored, I guess. I don't know. Kind of beige yellow, yellowish beige. Volkswagen, not even cool like Herbie, but my car always worked, which was important. It was for getting around, not for winning a car show. So I was pretty practical from that respect, I think. But Volkswagens were basically built to be the people's car that they could take care of. They could maintain it. There were all kinds of, here's how you make a hoist in your garage out of some milk crates and paper clips, whatever. There was always, from the olden days, how to maintain your car, right? So you can get to work, get to school, whatever you're doing. It was a practical choice. 1970, just a little bit older than I was. It never did let me down, really. I ran out of gas twice, I think. Once was not my fault, once was my fault. But the ability to push start, if you have a standard transmission in your car with a low compression engine, which Volkswagen was rather famous for, I think, you could almost push start the car in about 5 steps. Like, you'd open the door, you step out, you push the car a little bit, get it going, pop the clutch, starts right up. That had happened a couple times, but these were mostly minor things. Really, the big one where this happened was did I have a solenoid problem? Anyway, so a couple times I had to do that, but nothing major. Strangely enough, fixable. So learning how to adjust valves and timings and clean spark plugs, not to mention replacing the shocks, which I did one time. I think my dad and I replaced the brakes somehow, brake shoes on the front. Remember brake shoes back in the day? Changing my own oil. These were all consequential maintenance tasks that required a certain amount of understanding of the system. Now, changing your oil today, I think, requires training in modern cars. Some cars don't have oil to change. I just heard somewhere that someone received a bill, like a fuel charge. They rented a Tesla from Hertz Rentals. They returned the car charged to approximately the same level of charge, but they were charged $277 for a fueling charge, for refueling the car. Apparently, the argument was, but there's no fuel. Hertz initially didn't back down, but then once it hit the news, they were reaching out to refund the money. So it's kind of silly, but sometimes people don't understand how cars work. So they just assume a car would have to have gas. They didn't say, was there gas to be refilled? They probably said, did they refill the gas to the level it was before? If the answer was just no and not there was no gas to refill, $277. So I think, especially if it's a device you use daily and you depend on, car, air conditioner, refrigerator, whatever it is that you, if it were suddenly to break, could you at least figure out what's going on so you can identify who to call? If they tell you something ridiculous, you'll know, that doesn't sound right. So yeah, I think a functioning car and keeping it that way was a good learning experience for me. And it was a great engineering primer because you have to understand cars are very complicated when you really think about it. Volkswagen was not, from the 1970 model, was not in particular. But, you're dealing with transmission, so gears. You're dealing with internal combustion engine. You're dealing with fuels. You're dealing with oils. You're adjusting sparks and timings of those sparks, and brakes and master cylinders and brake fluids and leaks of brake fluids, and the list goes on and on. So there's a lot of different things that all kind of have to keep working. Unless you have a Cybertruck, then maybe not. On arriving at college, I did not bring my car, which I think was really a good idea. One of my eventual friends, I just met him, and he had a VW bus that he drove from Lubbock, Texas to Claremont, California. Along the way, we met, and then we would become friends, and later we would work on projects together and so on. And along the way, I found that collaborating on these somewhat technical matters of VW maintenance were also useful experiences to share knowledge acquired with my own vehicle, because the Type 3, I think it's Type 3 engine in the VW bus, not much different from the Type 1 in the Beetle. So we had some common topics to discuss in the VW maintenance arena. And I also learned from him, so I could learn about the differences and what worked on that type of engine versus mine and so on. And I could learn from him what he learned about his vehicle, and so we could share knowledge, collaborate a little bit. Every once in a while something wasn't working quite right, so he'd ask for my, what do you think? Take a look. So we'd jump in the van and try to look at the what's going on in that crazy German thing. So yeah, totally. The VW choice was a good one. I think if I had just owned a Toyota that never required any maintenance or oil changes or anything, like if I had a 1970 Tercel or Corolla or something, I probably would have run for all high school, college, probably would be still driving today. The academic pursuits while at Harvey Mudd College. I did pursue computer engineering in general. There was no, it was a general engineering degree, so I just concentrated on computer engineering and microprocessors, and our advanced microprocessors project, which was building a complete system from the ground up, wire wrapping a 68HC11 microcontroller-based computer, an embedded computer, right? So it wasn't a desktop computer. It was a small wire-wrapped, though, manually wire-wrapped computer to control this balancing robot, that inverted pendulum balancing robot. This was a project I worked on with my VW buddy. So we had obviously known each other all through college and worked on this project. We did some other things together as well. So this was sort of the culmination of collaboration on these projects. So some known, some unknowns. We already kind of knew each other's backgrounds and so on. So it was a good mix of using what we knew, using what each of us knew individually, collaborating, and then trying to figure out how to solve the problems we did not already know. So it was a pretty substantial bang for the buck on that project. And we did get our robot to balance, even though it was too heavy, because nowadays you would just get you can get a 6DOF or a 9DOF, 9 degree of freedom micro machine, a MEMS based device. It's a little chip you could put on your circuit board or however you can integrate it into your project, and you can get full attitude measurements and so on, acceleration, attitude. We had a spinning aluminum gyroscope with an optical encoder, and that's where the weight just started going up and up. We had lead acid batteries, because there was no lithium ion batteries back then. So we scrounged for parts. We built this thing. It was almost like assembling a Volkswagen from parts from a junkyard. So it did work, but not as well as it could have. And nowadays you can find balancing robots for, they're powered by a Raspberry Pi Pico, computers are, the processing power you get for $1 is more than fast enough to sample a MEMS 9DOF, do some calculations on acceleration and orientation, apply a motor control. Motor controllers are cheap. Motors are cheap. All these components nowadays, pretty easy to get to get and play with. And balancing robots are all over the place. Inverted pendulum problem is well known, well understood. So you can see these everywhere. So it was a good learning experience, a known problem with reasonable solutions. So overall, I give us an A. I think we got A- or something because we turned in our final report late. My first experience with a home-built PC, seeing someone building a computer that they were going to run Windows on or something, probably Windows, was an upper-class person. His name was Brian. I think he was 2 years ahead of me. No, 1 year. 1 year? I can't remember. He had a motherboard and a bunch of DIP chips, dual inline package, out. And I believe these were memory chips. And he was assembling probably a 386 machine. That was the contemporaneous Intel product. The Intel 386, probably, I don't know if it was SX or DX. Those were classic. We did have one of our computer science department at Harvey Mudd College had a sequent balance machine with, did it have 286s? But they eventually upgraded it to a sequent symmetry machine, which had multiple Intel 8386 parts for some very quick. What was there? They had a Unix called Dynix, I think it was. It was a multi-processing Unix that could literally handle failed processors. So if your 386 started smoking, it would just take that processor out of the rotation for task assignments and so on, job allocation, or however they termed it. So that was pretty cool. But the 386 here in a computer in this guy's, I think he was living in the apartments on campus. Like, oh, what are you doing? Oh, I'm building a computer. Like, oh, now I think this was around the time that we were doing our wire wrapping of our little embedded system. So I wasn't mind blown, but I remember thinking like, oh, I had never really considered attempting to find the parts to build a desktop computer. I was kind of stuck in the Apple world for a little bit too long. So to me, you would buy your desktop computer and you would use that to design things, to run MATLAB models for speaker crossovers or look at circuit diagrams or whatever. But that main tool was something you would buy. So this was a little like, oh, wait a minute, I didn't think about that. Strangely enough, Claremont, California did not have a Fry's Electronics or any sort of, nowhere near the resources we had through the, I guess the late 90s, early 2000s. Now, of course, Fry's is gone, replaced no doubt by online, Amazon, Newegg, etc. But back in those days, we had the engineering stockroom and we could cross our fingers. And that's why I worked there one summer. That's another story for another time. So my first two clinic projects, my junior and senior years, my first one, junior year, we designed, and in the first semester, which was unheard of, we basically learned how and then designed like schematics and Gerbers, a new bus-based demonstration system for our sponsoring company, ESL, a division of TRW. The board, we had two new bus boards made. They came back after the winter break, and we spent second semester debugging them. It was yet more hands-on learning about systems and building things that fit together in this tech realm. So in other words, we had to learn how NewBus worked, how to make a board like this, multi-layer NewBus board. All of this would come in very handy when I worked at True Vision, when we were making the NewBus-based Targa 2000, trying to get burst and block transfers to work on NewBus Max. By the way, it turns out only the 840 AV implemented the full Texas Instruments NewBus spec with proper burst and block. So transferring video at the time was really stressful to buses. And I think today when people can record 4K video or more on their phone, and they have no idea why would you need 6 RAID 0 SCSI 3 drives capturing data as fast as possible at 720 overscan and still drop frames. Those were the good old days. So yeah, I'd learned quite a bit about a lot of things in college. That new bus project was pretty important for later in my career. It was also pretty interesting. So the notion of not necessarily buying something off the shelf, but actually being able to assemble, construct, build, have a functioning system or integrate with a functioning system is pretty cool, actually. My first computer that I actually built for me, and remember, I was way too much of an Apple fan. I think a fan as in fanboy, not a spinning air moving device. I had an Apple IIe. Was my first computer when I was just out of 8th grade, junior high school. So I was a big fan. So the WAS computers were a different story. Those were okay. So I won't fault myself for liking the Apple IIe. That's where I first learned about, like, oh, I can put another processor in there, my Z80 card, so I can run Borland Turbo Pascal, and my memory expansion card, and using the joystick connector, which I think was a 24? Was it 24-pin dip? 24? 16? So being able to hook things up there and connect that to my Radio Shack electronics kit thing, and I got a breadboard at some point. So yeah, the Apple IIe played a role in my early nerdy engineering days somewhat. But I did lean far too much into the world of the Macintosh. I was fascinated by the first Mac, the 1984 commercial, the first Mac. They had to borrow a Mac program so you could try it out at home. So we had one for like a week or two. Totally fascinating. I really had no idea how cool the 68000 was. It did lose the battle of processors back then. What could have been if the 68000 had really taken off? Not that it died. The 68040 was still around, and I think was there an 060? I can't remember. But yes, I was overly fascinated by the Macintosh. I was taken in by its Jobs mindset, closed system that works the way Jobs intends. So while I was at Netscape, so through the years I was exposed to different kinds of computers. I had to deal with Windows or Mac OS or whatever. Even though Linux came out just when I was graduating from college, there was much more Unix around. So I was, we had the Sequent Symmetry, we had Spark Workstation, Sun OS, we had the VAX, HMC VAX running VMS, which not all bad. I don't know if OpenVAX is still around. OpenVMS. You used to be able to emulate a VAX on an Alpha processor with a microcode download. Anyway, so my first build, though, I was working at Netscape. I was surrounded on all sides by different computers running different versions of Unix, AIX, SunOS, what's the other one? Solaris, IRIX, HPUX, more. There were more than that. Plus Windows NT, plus Mac, 68K Mac, PowerPC Mac. Somebody had BOS running with Navigator on it. The list went on. And so I was like, there's so much computing around here. I'm going to build my first computer, which I did. So I was running Debian Linux on my Compact Desk Pro with a Matrox video card. So I had to get a commercial X server that would support the Matrox card. So that was an interesting experience. A lot of things have changed over the years. No more PCI entry points having to be moved around and so on. So I figured, okay, I know how this works. Oh, by the way, the Debian recommendation came from my Volkswagen buddy, who I said, hey, I'm thinking about trying out Linux. And he said, try Debian. It pretty much works everywhere. And that has still been true. They did kill off the Alpha port. It's too bad. But my Alpha also got killed off a long time ago. So I chose a Tyan dual CPU motherboard with two 200 megahertz Pentium Pros, not those 180 doohickeys, with, I think they had 256K of cache each, something like that. I think it was 256. I don't know if I could get 512 at the time. I think that would come later. These were Intel parts, by the way. Memory, few megabytes. I don't remember how much, but it was probably EDO, extended data out, way back in the day. A Matrox video card, of course, because now I knew that that worked. A 21-inch SuperMac CRT monitor for my first job at SuperMac when I moved to Silicon Valley. A CD-ROM drive, an IDE hard drive, a floppy disk drive, and Debian on CDs, which I purchased and had sent to me through the U.S. mail, because at the time I could only access the internet at a blazing fast 33.6 kilobits per second. Thank you, U.S. Robotics. Back in the good old dial-up days. I was using Linux, of course, and various flavors of Unix working at Netscape. I had discovered Slurp, S-L-I-R-P, which I have linked in the links section. Hey, it all comes together now. So Slurp allowed one to dial into their netcom.com shell account, for example, and it would magically configure PPP so that my little Linux, and I actually started using Slurp with my Mac. I had a Macintosh. Blech. So, but I got it set up so I could make a PPP connection through my Netscape shell. So I was able to start experimenting with actual Linux networking. And of course, that's stuff we still do today. So that was pretty seminal. So I had a pretty serviceable network connection at home, even though it was only over dial-up, but I could go to work and use the network there to download Debian updates and so on. So I became familiar with how that process worked. I think I had a zip drive. Yeah, I think I had a zip drive pre-click. I might even still have that zip drive somewhere. I don't know, maybe. But so zip drive, go and get the updates, bring them home, apply the updates. So every once in a while, I was keeping my machine up and running, and I had my collection of O'Reilly books with the animals on the covers, learning about all the different aspects. We had a computer store in Silicon Valley called Computer Literacy. You could basically spend a week. It was a lot like a college bookstore. The really, really good one was on First, somewhere in San Jose, and then there was a smaller version very near the Thai restaurant that I used to frequent daily in basically a disconnected but same giant parking lot strip mall on Lawrence Expressway. So technically in Santa Clara. So this was my foray into like, oh, I can make my computer and I can make it do things that I want or need it to do, and I will learn how to do that. And so I did. So I had all manner of services, configuring mail servers, and Linux printing was always an adventure before the Linux printing project really kind of settled into functionality. The joy of figuring out whether peripherals worked. Like, will this work with Linux? There was no Google yet, although that would come later, not much later. I remember driving by Google while I was working at Netscape and thinking, wait, what is that? It was not the Googleplex. It was a small place. I noticed the logo from the street. My phone was almost going to make some noise, so luckily it didn't. Anyway, phones are another topic. Closed system, no good. So that was my first computer. I used that computer for a long time. Building for pay. So I built it at Netscape. I left Netscape to work at Umax, which was PowerPC. So I still used my dual Pentium machine, but they gave me an S900, I think. I had my PowerMac 7500, which I turned into a NAT machine to connect to our DSL connection. So PowerPC interposer for our network server and network address translation for our DSL connection, which was substantially faster than dial-up. Those were fun times. So yeah, my next gig at Umax, where we were making PowerPC platform, or if you're from back in the day, the Chirp, Prep, or PPCP, we kind of were working on all those, but eventually PowerPC platform to run Windows, Windows PowerPC, Mac OS, of course, Solaris PPC, and hey, Linux. Linux PPC was coming along very nicely. In fact, I can't remember his name, Paul something, and then there was Victor Yodakin working on real-time Linux. I somehow managed to get them some Yellowknife hardware, which was the IBM PowerPC development machine, so that, what was his name, Paul something in Australia, could work on Linux PPC. So there was enough Linux PPC to be running on my desktop at my S900 at Umax. So it was really, it was a command line, right? There was really no GUI, no graphical, no Xorg running. But what ended up happening, so they hired me to be like the person that would be in charge of the multiple platform support, because I had been using all these different platforms, machines and operating systems and stuff at Netscape. So I was not only interested, but familiar. So one day, the firmware manager says, oh, we got the drop from Apple for the build that we need to do to continue our development on our machine, which was going to be Mac OS compatible, of course. This manager was a total Apple fanboy, through and through, up until, well, he would later move his head mostly up his butt. But he said one day, oh, they dropped the software, but it can't build in MPW, which was Macintosh Programmers Workshop, which was its own, I'm not going to say IDE, but it was its own build environment. So he was like, it's all Make and GCC, because Apple was building on RS-6000 machines in their development process. So they were building on real power machines for cross-compiling to PowerPC. So I said, oh, I can build this on my Linux PPC machine. And the look I got was like, wait, what? No, I had no idea this existed. So yeah, I built the image, whatever. Well, it was some firmware image or something. A couple minutes, done. I'm like, yeah, I got Make, GCC, the LD, everything. Got everything you need. They said, do you want to be in the firmware group? And that was the beginning of the end of my being some sort of a liaison. So my day-to-day work became PowerPC assembly language, Forth for the open firmware, some C, busting out a logic analyzer or oscilloscopes to check signals on boards. We had these, I think we had a dozen different prototype boards. Each one developed its own personality with mods, cut wires, lifted pins to make things work, and so on. We were watching memory bus accesses, probing configuration prototype chips. Probing and configuring, probing and setting the configuration, I guess. I do have these notes that I made, so I remember all this, and of course, I have typos. Nowadays, backside cache is everywhere. People don't even talk about it like it's a thing. So the PowerPC 603E, I think it was, codename Arthur from Motorola, had backside cache. So we at Umax had our little interposer upgrade card. So we had a little, I can't remember what the code name of that was. We had Arthur mounted with 2 memory parts for a backside cache. So this was different from the different from the Pentium Pro caching scheme. Backside cache was implemented differently, be more performant, and so on. So we had to figure out how to configure the backside cache. So you had to probe for how much memory you had, set a few bits in some status registers that were supervisor, ring 0, on a machine that we didn't have ring 0 because of the Mac's stupid, anyway. So learning how to make that work was some debugging and reverse engineering and being very familiar with how computers work in general. We had our GoldenEye 604s from IBM. I may be switching those. It might be, was Arthur from IBM and Motorola? I think Motorola was GoldenEye and IBM was Arthur, now that I think about it. Anyway, so having that, the familiarity and the wherewithal to do those deep dives and to learn how things worked and knowing nothing was essentially postgraduate work on a computer engineering mini master's degree of some sort, right? So tremendous learning experience. Ultimately, that experience was better than most of the people I met there, but that's another story. So eventually I was building for pay, as I said, on to Philips when Umax started shutting down. So we built LCD controllers, which were not sexy, 8051 based. At the time, Philips Semiconductor was like the largest producer of the largest variant selection of 8051 based processors. 8051 was an Intel invention, if I recall, but they were not totally invested in the microcontroller market any longer. So Philips had the crown for a good long while. So we were making 8051 based liquid crystal display controllers for desktop monitors. It doesn't get more exciting than that. But hey, it was fun. It was actually pretty interesting to learn about process at a company like Philips, which was 160,000 people worldwide at the time. But we had our own little lab space, so a lot of the UMax crew moved over, all the good ones. So learned a tremendous amount from Jose, who was employee number 104 at Apple. Got to work with Woz directly. So a lot of experimenting could be accomplished, and Jose would just say, "Oh yeah, bro, let me build that for you." He would stuff a board right there. So he could do some amazing assembly and repair and debug and jumpers and trace cuts and all manner of things. Like, yeah, he was pretty good. So we used to prototype things, bring them up. Power on, Intel called it power on. Back then we called it bring up. So when you're bringing up a new system, you have this newly assembled piece of electronics. You've never applied power to it. You're like, "Ooh, I hope no wires are crossed or things didn't get the errors didn't get introduced anywhere. Certainly not my errors." So during bring up, you'd power it up and see if it worked. And so in the first couple of seconds, you're smelling. I don't know if that will get truncated, but you're taking strong inhalations to make sure you're not catching any smoke or smelling the sort of chemical burning smells of the there's chemicals on the board. So we used to power up, bring up boards, and after weeks and months, it was very satisfying to see your design work without any smoke or fire. And look, it works. So that was pretty fun. That was on par with the UMax experience. Totally different because it was embedded versus, full-blown desktop workstation style stuff. But the continuation of my mini master's degree, perhaps. And then when I departed Philips, and my final company that I worked for as a consultant in Silicon Valley, right before I moved back, was Leapfrog Toys, Leapfrog Enterprises, something like that. Leapfrog. So we were working on 8051 based ASIC as the core cost reduced platform because toys have to be cheap. It was a very practical, cost sensitive device that they had settled on. And so all their toys were based on the same fundamental components. And there was a prototype with different kid-friendly interface elements on pieces of wood, so you could experiment with all the sensors and the general interaction, even though you didn't have finished plastics and industrial design and all that. And it was really interesting to prototype, to write the code for this mechanical system, dials and buttons and beeps and screens and all this stuff that were in such a prototype state. Kind of had something similar in the Newton group when we were working on the Message Pad 2000. We had definitely serviceable but prototype message pads, so they were not 100%. I didn't have a prototype but yeah, through the years, the ability to build on and interact with prototype hardware, absolutely invaluable. The Leapfrog work was kind of a culmination of what I had learned over the years, coupled with the joys of working with an awful company. That I thought I was going to be working with the people in the Los Gatos office were a lot like Santa's elves, if you can imagine that. The backstory of Leapfrog is kind of interesting, but the corporate overlords, because they wanted to go public, were much more driven by money than educating kids. So not a great. I declined a job offer and moved to Phoenix, ending my Silicon Valley career mostly, for the most part. Not my career as an engineer, but just the time, my network, and it was a dot bomb. Everything was failing. September 11th would come along. soon after I moved to Phoenix. So yeah, but the people in Los Gatos were cool. The company, not so much, but still a good learning experience. Definitely one of the shining stars in my galaxy of education. Makers and innovators, really, to be honest, the real combination of all of these stops along the way through at the time, it would have been more like 25 years. Now it's 30. So it's been 24 years. Now it's 30. Of various educational experiences in my professional career, was a role in the Maker Innovator Group with Intel Corporation. That was where I got to live in Vegas, but travel 80% of the time. So I was a part-time resident. So I was in a lot different parts of the U.S. I was in Europe frequently. Didn't really get to travel to Asia. That would have been probably not only fun, but it would have been a different view of things. But I was more in France, England, Ireland, Italy. I didn't get to Germany from there. Anyway, so that was a lot of interaction with some very smart people. I had some of my time spent in the lab, in the Intel lab facilities in different places, working with very smart people. The Galileo project, which was developed, I think, in 30 days, which was unheard of at a company like Intel. The Galileo was developed by the team in Leakslip, some very talented lads in a closed room, probably locked from the outside. Turned out the first Maker Innovator product that was launched at Maker Faire, and that's when I entered the picture. So I got to know the Arduino people, the team in Ireland. I spent more time in Ireland than in any other Intel facility, strangely enough. So the Leakslip team did a great job. I worked on Edison a little bit with the Toulouse team. It was basically a finished product, so I went there and learned painstakingly how the Edison functioned. Edison would make a lot of appearances in hackathons, so I was able to bring far more familiarity with the system, hardware and software, than the other mentors from the group at Intel that was running them. So very practical to learn how a system works in the lab from the people that designed it. So you're kind of in the know. And then when you go out and try to work with makers and innovators at hackathons, you can answer their questions directly and correctly, not give them incorrect information. And that's where I will leave that part of the story for another time. The Arduino 101, which was kind of a joint venture with Arduino and Intel, and I cannot remember where they were developed. I mean, probably mostly in Ireland, but also the Curie. I can't remember who developed that. That was somewhere in Oregon, I think, probably Hillsboro. But anyway, so the Arduino 101, and then it didn't really get out to the world, the Joule, which they were really aiming to be a drone controller. So they probably would have gotten that wildly wrong. That was a Hillsboro production. So yeah, I was traveling around to all these places, working with the Intel engineering side. And at the same time, I was applying this hands-on knowledge that I would gain from, being in the lab. And plus my own experience. I had been doing this for, like I said, something like 24 years, I think, to mentor participants at various hackathons all over the US and in some parts of Europe. Not to mention the maker fairs that I would attend in Rome and New York and San Mateo, and some mini maker fairs. And as well, a little reality show we did on TBS with Mark Burnett of Survivor fame called America's Greatest Makers. Direct practical application of all these things to enable others to do the same. So I was basically passing the torch, sort of. I maintained control of my torch, but I was helping, maybe passing the flame. So some very smart people, the people that attend hackathons and actually do so to actually build things or to learn or to try out ideas, these are some very smart people. And it was absolutely eye-opening to work with so many in different places. Kind of the thesis statement of hackathons is it doesn't matter where you are, doesn't matter what your culture is, doesn't matter what your language is. There is a sort of maker, not ethos, but mindset. There's some ethos too. I mean, even in a competitive hackathon, everybody helps each other, right? Nobody's really there to be cutthroat. If you're ever at a cutthroat hackathon, go to a different hackathon. But to see so many people, no matter where you were, no matter how old they were or how young they were, so many people that were interested in trying out ideas and learning from each other. And sure, there were prizes and so on. And it's always fun to have your project work after. If your project is demonstrable and functional after working on it for 40 hours and like starting from nothing, that's reason to celebrate. And if yours works better than everybody else's, you deserve the gift card or whatever the prizes were. Sometimes they were substantial. So this was an interesting time, probably considering the fact that I took an Intel layoff package, as did 12,000 other people, and Intel exited the maker innovator marketplace. You can't make money selling to kids. No kid is going to buy 1 million core processors. They just want one Edison. So it was not a good fit for Intel's market, their strategies and whatnot, and probably most things aren't nowadays. But for myself and for my career path, as far as working for big companies, definitely, since I don't really want to, I would never work for Intel again. I would never work for a company the size of Intel. Too much empire building, too much chaos and politics and so on. But as far as going out on a high note, definitely a brilliant learning experience and exposure to a lot of very smart people and the way things could work. If you think your city is going to be the next Silicon Valley, think again. You have to have a population of people with that maker mindset, makers and innovators, and people who show up and try ideas out. And then, oh, there's prizes, not the other way around. So brilliant stuff. So over the years, the title of today's episode is about building computers. So over the years, I've built my own computers. I don't remember, aside from laptops, and Let's Hope Framework continues what they're doing. But aside from laptops, I cannot recall the last time I purchased a computer. So laptops and phones and things. But as far as a computer on which I will run Linux and develop my whatever ideas and surf the web and check my mail and all that. So much like my dual Pentium Pro, I've tried building different types of systems, almost always with AMD parts. I'm trying to recall if I ever, other than those Pentium Pros, did I ever buy an Intel CPU? And I believe the answer is no. Because when I saw the K6 3 Plus, I think it was, K6 2, K6 3. So and this was the day and age when you had VIA, you had the Centaur processors, there was some other, did I say VIA? Yeah. Who were the other ones? There was AMD, VIA. Anyway, there were several companies making Intel clone processors. But to me, for some reason, AMD, and of course AMD got the whole thing started with their lawsuit about IP sharing and fab collaborations and so on. I'll leave that for you to read. But AMD to me always felt a little bit scrappier, which they still are, I think. They seem to be innovating without resting on their laurels so much. I had, so I said K6 machines. I built several of those for various uses. Even though I worked at Intel, I still had AMD parts. So aside from my laptop, which had an Intel part in it, now it's a lot easier to find Ryzen-based laptops, which I have one. So I really have no need to buy an Intel laptop ever again. I built a dual Opteron machine in a cool little cubically shaped case on wheels. Dual Opteron was pretty snappy, and so I had a ton of memory in it, and that was my kind of main Linux server. Did all kinds of stuff on that. Mail and mail servers are the big thing. I don't know why people hate email so much. It's so cool to set up your own mail server in a few minutes. It's great. Built some Athon machines. I had an 800 megahertz Athon machine forever, and then eventually, when did I build? Did I build this right? So right now I'm running a Ryzen-based machine that I think I built 5 years ago, and it runs fine. Do I want to build a modern computer so it's a little bit snappier? Sure, of course. which one to buy? Well, now that AMD is on a tear launching processors left and right, you actually have to listen to the reviews and see, because a lot of people are doing a tremendous amount of work measuring performance, seeing which motherboard, CPU, memory combinations not only work, but work the best and which are stable. I'm not really an overclocker. I really have no need to introduce those problems. Cooling, total system power. People are really measuring these things now and doing some in-depth comparison and analysis, which I think is fascinating. So yeah, my Ryzen Mini ITX machine with, I think I have 16 gigs of RAM, a ridiculously far cry from my first dual Pentium Pro machine, but yeah, it's totally functional. You can build a very fine machine. You get to use the parts you want, and they're probably a little bit more expensive because you don't have quantity discounts. You have no economies of scale. But at the end of the day, you have a system that you wanted, and it works the way hopefully you wanted it to work. And they're so modular now. It is so much easier. And my building my Pentium Pro machine was not soldering memory chips onto a motherboard or cutting traces or anything like that. Still modular. So you're sliding memory DIMMs. We're on DDR5 now, I think. Double data rate. By the way, that means you're doing memory transfers on the rising and falling edges of the memory clock instead of just the high. If transferring occurred on a logic level 1, you're now clocking on the edges, so rising and falling edges instead of the level between the edges. So I think it's DDR5. Ridiculously fast memory, but you just plug these things in. By the way, tremendous amount of time is spent on transmission line effects, on where you put your DIMMs. Why do I have to put the DIMMs close to the processor first? Because you're putting resistance on the transmission lines of the signals and all that stuff. So just more stuff to understand, but most people don't. Most people don't even build their own computers. But yeah, so modular systems make it so much easier now. And there are so many people making YouTube videos, in-depth analysis, even people running Linux. So you even get the Linux insider, like, okay, this part works great. Here's how you configure it and so on. That was never available back in the day. So now you can actually build the computer you want, running the operating system you want. There are a plethora of Linux distributions to choose from. The sky is the limit, and these YouTubers are reviewing configurations down to latencies and total design power, and whether you need liquid cooling, and what your margins are on power and heat and cooling and everything. They really should use NVMe. Should use well, of course you should. What about hardware RAID? No, get rid of it. So everybody. There's just so many opinions, and you can really start to see when they line up. Like, oh, Ryzen's really the way to go for most things. And a lot of reviews are gamer-based. So, like, if you're a gamer, you should still stick with the Intel i15000, whatever. Yeah. But if you just want to build your own computer, if you're me, for example, you're like, man, just to say I did, I would love to build a Threadripper or an Epic for no reason whatsoever. But yeah, it's exciting and kind of fun to build a system because you actually get back to the how does this all fit together? What are the upsides of this part? Cache sizes, chiplets, whether there's a CC NUMA, cache coherent non-uniform memory architecture, just amazing stuff. Things are moving so fast, it's ridiculous. Not to mention GPU technology. When I was working at Netscape, our group manager's wife was a director of engineering at 3DFX, when the Voodoo card was like the fastest card ever. And that thing would probably barely keep up with anything nowadays. So yeah, the good old days. I need to build another computer one of these days, but I mean, I don't need to. To be honest, it takes longer to do the research than it does to build the computer. So once you have the parts and the power, should I get the gold power supply with the whatever ratings? Is it going to be the single rail, the Intel proposal for 12 volt single rail? I don't know. So doing research on the next build takes longer. even with all those YouTubers, because now there's an embarrassment of riches, the plethora of choice, or the paradox of choice. So, where does this leave us? I've described a journey that has been centered on building of computers, but I obviously started out with Legos and Lego and Tinker Toys and changing the oil in my Volkswagen Bug and hackathons and embedded LCD controllers and educational toys. So these are all kind of variations on a theme. So far, especially with my work with Innovate for Vegas Foundation, which is essentially one person for the last almost a year now, a lot of Gen Z and some millennials or Gen Y are laptop bound. They rely heavily on cell phones or similar. These are closed systems, mobile devices. They, even if they're a developer, even if they went through a boot camp or they're self-taught, they have their MacBook probably. I've got the latest M2 MacBook. Okay. Do you know how it works? No. So they work on these closed systems. They learn how to program JavaScript, and that's all they need to know. Even though they have no idea why their system doesn't work, why there's so much latency, why things take so long how does caching even work? I don't know. So while JavaScript has accomplished enabling more people to program with less familiarity with the systems on which they're programming, that will begin to show itself more and more. And when you introduce, by the way, artificial intelligence writing your code for you, you now will have no idea what the code is doing, why it isn't doing what you hoped it would be doing, and why the underlying computer system is unable to deliver the code running the way you thought it would run. And you'll only be able to shrug and say, explain to me why this code doesn't work, ChatGPT 5, 6, 7, 8, 9. So fundamental understanding, intellectual curiosity, these are all things that take time to develop. Lateral thinking is a skill that will be invaluable if you enter most fields, actually. But certainly solving problems while being able to collaborate and measure, specs and features and whether or not things work. There are too many things to learn if you are in the tech sector about how computers and technology work, by actually building them, by taking them apart, by deep diving, by understanding how these things work, rather than just accepting the little cell phone box, opening it, oh, look, my new iPhone. Do you know how it works? No idea. And I did work at Palm on the Pre, so I worked on, and the Pixie. So practical experience working on cell phones. Also worked in the Newton group, so PDA experience, touchscreens and strong arm processors. So all this is partially a result of the emergence of technologies and form factors that are appealing and which converge with the need for mobility and constant connection. So in other words, lifestyles and cultural expectations about being on the move. More students have computers. So having a laptop that you can carry to class and carry to wherever to do your homework or do whatever you're doing. I'm going to take a side gig doing websites, or I'm going to teach myself JavaScript. Okay. You can also teach yourself C. You can teach yourself Rust, Go, Python, SQL. There are a tremendous number of possibilities when you have a computer that you can throw in your backpack at a reasonable price. But more often than not, people are treating it as a closed, what we call a black box, and they don't have much curiosity about what goes on inside. If your laptop breaks, you just get a new one. Is it really broken? No, the power. I had a computer with you could put a micro SD card in it, but the card eject thing was broken, so it would only eject. So, it wouldn't lock once you put it in. So I'm like, okay, tape. So I know exactly what's going on there. I don't need to get it fixed. I just need to put a piece of tape on there, and I can keep an SD card in there, which I would use for logs. Anyway, knowing how things work, whether it's a computer or how cooking works. Anthony Bourdain famously said everyone should know how to make an omelet, because you understand a lot of things about cooking if you can make an omelet, if you can make a good omelet. So I think people have migrated their mindset to convenience over curiosity. We see fewer people interested in building their own technologies in general. Now, this is not to say there's none. Luckily, there's an alive and well maker community still around the world. Even though it is much easier today than it has ever been to do these things, It's startling the number of people in the web dev world who are not interested at all in the underlying technologies of the computers they're using. The cloud is literally out of sight, out of mind. They get it configured. They don't really care. Kind of wonder if that's why cloud costs can run out of control, because people don't take the time to understand the actual systems. They just use the GUI. So luckily, there's still a population of makers, like I said, around the globe who do, that's boldface, do build their own versions of a lot of things. Not everything is a computer, so I've used this as an example. A lot of makers are into robotics, or they'll build embedded systems with displays and touchscreens and cameras or other sensors. I myself have our CERT radio project, which I have not spent enough time on, to connect Community Emergency Response Team, CERT, volunteers when for some reason they seem to believe, especially here in Vegas, yeah, we'll just email you in a crisis. What if email's down? So how about LoRaWAN? How about existing or new existing technologies that allow peer-to-peer wireless communication? So you can connect all your volunteers without relying on email or cell phone towers, right? They can actually broadcast signals over, I believe it's like 2 kilometers. You can add an antenna and get a little bit better range. Oh, and think about that. We just used Gmail. Have you ever even set up your own mail server? Do you even know what the what the greeting stanza is for a ESMTP server? EHLO. Anyway, so there's a lot of things that people do build. There are people that do still do things. They have intellectual curiosity. These are the people that will make things change. They will make things better. Something as simple as building your own computer is a gateway to demonstration of flexing, stretching of the muscles in your mind and body that are essential for lateral thinking, innovation, thinking outside the box, and making things better. Hey, Phillips, let's make things better. That was so optimistic a tagline. These are the personalities, these traits that people have to be curious, which will drive innovation into the future. Fingers crossed. That brings to a close another episode of The Quaggling Sand. By the way, Quaggling Sand, in case you're curious, I try to say this in every few episodes. Quaggling Sand is when I was something like, whenever I was playing with those Tinker Toys, when you say you sit on your foot or you are leaning on your hand or something, and you block circulation for a period of time, and then you stand up or move, and your arm or your foot is numb. Can't feel my foot. And then as the circulation returns, all those nerve endings are being, and so the pins and needles sensation that you probably call it, I used to call quaggling sand, a term I made up. That's how lateral thinking works. So a good place to end this episode. Thank you for listening. Thank you for checking out buymeacoffee.com/DanHugo, ko-fi.com/DanHugo, to keep in touch with the various projects, especially, I promise, we're eventually moving towards some cooler things. And the In Las Vegas project has taken over the old Instagram account for Innovate for Vegas. So hopefully building computers will be just one of the many things being built around here. On that note, thank you so much. We'll see you next week, or we'll hear from you next week, or you'll hear from me next week, something like that.